In this video we're going to look at an exam question involving a ball being dropped vertically. Now the key thing to realise is that when this ball is dropped, the only force acting on this ball is that due to gravity, and gravity will give a constant acceleration to this ball of g downwards. Now whenever we have a question involving constant acceleration, we're going to use the Suvat equations. So whenever we have a Suvat question, I always find it's easiest to write Suvat and then fill in the blanks. The other important thing when we have a Suvat question is we have to define a positive direction. Since the ball is travelling vertically downwards, I'm going to say that the downwards direction is my positive. So S, that's the distance it travels. Well, if you read the question, you see that it starts at height h and ends up at 0, so it moves h meters downwards. So S is just h. U is the initial speed. Well, the ball's released from rest, so it initially has, say, initial velocity of 0. V is the final velocity. We don't know that. If you see in part A, that's what we're actually trying to work out. A is gravity, and that's acting downwards. Now, since we're taking downwards as the positive direction, then we just need positive g here, which we're going to say is 9.8 for this question. And t, the time taken to hit the ground, is 1.5 seconds. Okay, so in part A, we just need to work out the speed when it hits the ground. So that speed is this final v. So we're going to use the Suvat equation. V equals u plus at. And we'll just fill in the values from our Suvat. So u is 0, a is 9.8, and t is 1.5. So working this out, we get that v, our final speed, is 14.7 ms to the minus 1. And that's velocity acting vertically downwards, or speed of 14.7. Okay, that's easy enough for part A. For part B, we can still use these same Suvat values, but now we need to work out h. Well, h is s in our Suvat equation, so we want a Suvat equation that's involving s. Well, the easiest one to use here is s equals ut plus a half at squared. You need to learn these Suvat equations. This is one that comes up a lot. So let's fill in the blanks. S is going to be h, u is 0, t is 1.5, a is 9.8, and t is 1.5. And so we're just going to work this out. 0 times 1.5, 0 plus half times 9.8.1.5 squared. You work that out and you get 11.025, and this is meters. So h, the height of the ball starts above the ground, is 11.025 meters. Okay. And again, finally for C, we're going to use the same idea. Now we've got to work out the distance that the ball has fallen when its speed is 5 meters per second. So now we've got a slightly different Suvat setup, so I'm going to change some of these. So now we're working out the distance, so we don't know what S is. Now we're no longer looking at when the ball hits the ground, we're looking at when its speed is 5. So we're looking at a final speed of 5. And we also don't know what t is anymore. We knew t when it hits the ground, but we don't know the t when its final speed is 5, so that's unknown. Okay, so we want distance, so again we're going to use S, an equation with S. We don't know t, so we need an equation that doesn't involve t. So an equation that doesn't involve t is v squared equals u squared plus 2as. That's the equation that doesn't involve t. And we're just going to fill in our numbers. V is 5, so 5 squared equals 0 squared plus 2 times 9.8 s, 25 equals 19.6 s, and that gives s equals 1.276 meters.